Hello and welcome back to Math with Miss Murthy's. Today's lesson is lesson 4-6. We're graphing reflections of points in the coordinate plane. As usual, pause and do the warm-up problems, all the check problems on your own. Also try to do the talk about it and the think about it so that when we talk about them in class, you have some idea of what's going on and our discussion will help refine your understanding. All right, so when you look in a pond and see yourself, or a mirror, when you see yourself, that's because of the light waves and laws of science. So reflection is the bouncing of light rays off of a surface. When those waves reflect off the smooth surface, the reflection happens to be a mirror image of the original figure. Okay. Similarly, if you look at the number line, you'll see that the points -4 and 4 are opposites. They are the same distance from 0 in opposite direction. So you can literally imagine that this is like a mirror over here on 0. Okay. So similarly, in a coordinate plane, the points -4, 0 and 4, 0 are the same distance from the origin in opposite directions. And these points are reflection across the y-axis. My y-axis is my mirror in this case. Okay. A reflection is a mirror image that is produced by flipping a figure across a line. So in this case, it goes from here to here, or here to here, or it could be across this line. Okay. Now, when a point is reflected across the y-axis, which means your y-axis is a mirror, you're taking the reflection across the y-axis, your y-coordinate is going to stay the same because the distance from that y is the same for both. What's going to change is the x coordinate, and that is going to reverse the sign. So in one case, if your original point was a positive, the mirror image, which is the opposite, is going to be a negative. However, if you started off with your point being negative, the opposite of that, the reflection of that, is going to be positive. Okay. Similarly, when you reflect a point across the x-axis, the coordinate is going to stay the same. The y-coordinate is going to flip its sign. Also, when you are writing the names for the coordinates, so when you reflect a point across a line, you name the reflected point using what's called the prime notation. So in this case, where if your point -4, 0 has the name or label A, its reflection across the y-axis is going to have the label A prime. Let's look at example 1. Write the ordered pair that is a reflection of A, which is -3.5, 2 across the x-axis. So my mirror is my x-axis. Okay, so we're going to find the point on the coordinate plane. That's the same distance from the x-axis as the original point. In this case, this point is 2 units away. So we look for something that's 2 units away in the opposite direction. So when a point is reflected across the x-axis, your x-coordinate is going to stay the same. The y-coordinate is an opposite. So now you have the reflection of A, which is -3.5, 2, B, -3.5, -2. All right, pause and do the check problem on your own. All right, let's take a look at example 2. We want to find the point on the grid that is the same distance from the y-axis as the original point. So when a point is reflected across the y-axis, we know that the y-coordinate is going to stay the same. The x-coordinate is going to become the opposite. So the coordinates of the reflection of S, which is -2, 2. So my y-coordinate is going to stay the same, which is 2. My negative becomes a positive. So S prime is 2, 2 across the x-axis, across the y-axis. Pause and do the check problem on your own. All right, let's take a look at example 3. we're going to identify which axis we reflected on just by looking at the points. So my point A prime, which is negative 2 and 3 quarters, comma negative 4, is the result of reflecting A, which is 2 and 3/4, comma negative 4 on the coordinate plane. We have to identify the axis across which the point was reflected. So let's take a quick look and locate these points first of all, right? This is my coordinate plane. This is my y-axis. This is my x-axis. Negative 2 3/4. With x is negative 2 3/4, comma negative 4. It's probably going to be, let's just say it's around here. I'm not drawing this to scale, okay? This is my point A prime. My point A is 2 and 3/4, which means that's traveling in this direction, comma negative 4, and that would be traveling in this direction. So my point A is over here. So across which axis have we reflected the point? The point's reflected across the y-axis. Okay. So now we're going to complete the table to compare the coordinates of the original point and the point after reflection. So my original point, let's see, is 2 and, let me make this brighter, 2 and 3/4 for the original point. The reflected point is negative 2 3/4. The y coordinate is negative 4, negative 4. Now the way you can tell is your y coordinate stayed the same. Your x coordinate are opposites. Therefore, you can conclude that point A was reflected across the y-axis. Pause and do the check problem on your own. All right, that's all I have for you today. We will work on the applied problem together in class. See you in class. Ciao.